Hello everyone. In our previous lecture, we dealt with finding inverse using determinants, in which we have found determinant, then minus, then cofactors, then adjoint, and finally inverse. Now let us deal with the actual question that we're gonna have by using all these few things that we have learned in our previous lectures. Let us see. Question is, solve. We have three equations given with us: x plus y plus z is equals to 3, then 2x minus y plus 3z equals to 4, then x minus y plus z equals to 1. So we have three equations and we want to solve them, but by matrix method. Now again we can enroll few steps in that, and the first step is we can say we have to identify three matrices in this whenever we are dealing with this matrix method. The first matrix is called to be coefficient matrix, written by A. Second matrix is called to be variable matrix, written by X. And third matrix is called to be constant matrix, written by B. Now, as name implies, what is a coefficient matrix? It is a matrix of coefficients. Just say, check it out. What is the coefficient of x over there? 1. Y 1. Z 1. So written 1, 1, 1. What's the coefficient in second equation? 2, minus 1 and 3. So what I've written over there? 2, minus 1 and 3. What is the coefficient of x, y, z in third equation? 1, minus 1 and 1. 1, minus 1 and 1. So what I did, I just written the coefficients of x, y, z, nothing else, and that is called to be your coefficient matrix. Is that clear or not? It's quite simple. Just writing the coefficients. In first column, all coefficients are of x. In second, all are of y. In third, all are for z. Or I can say in first row, coefficients of first equation. Second row, coefficients of second equation. In third row, coefficients of third equation. Then second matrix is a variable. Can you check it out? How many variables are enrolled in this? Yes, 3. That is x, y, z. So I've written x is equals to x, y, and z. That is your variable matrix. And one thing you should notice, I've written that in a column. Although I can write that in particular row as well, but I'm writing in column just because of a particular condition that I want to attain. We'll discuss little later. Third is the constant matrix. Constant matrix, we have used the coefficients, we have used the variables. What is left? 3, 4, 1, and that is nothing but the constant matrix. So you had found all three matrices: coefficient matrix written by A, variable matrix written by X, and a constant matrix written by B. And if you're gonna check that, if I'm multiplying with the A with X, and putting it equals to V, if I'm solving this, I'm gonna get all these three equations back. And that is the purpose that I've written these in a column. Because, just check it out. What's the order of this? 3 into 3. What's the order of this? 3 into 1. Because these two are same, I can multiply them. Otherwise, make it over order chalega, so I will not be able to multiply them. Is that clear or not? That's why I have written in the same order. So if you are multiplying A with X and you are putting it equals to B, you are getting all these three equations. That means this thing is representing these equations and these equations are representing this thing. So my target is to solve the equations. That means I want to find the value of X, Y, and Z. That is, I want to find the value of X, Y, Z. It means ultimately I want to find the value of this particular X matrix, which is our variable matrix. So let's do little bit of criteria over there. We have A, X, and B over there. Just pre-multiply with A inverse on both sides, here and here. A inverse, A inverse. And we know that A inverse into A is nothing but identity matrix. So I've written them I, X is equals to A inverse into B. But I know identity works as 1. So X into I will be X. So that means finally X is equals to A inverse into B. That means to find X, what I have to do? Firstly, I have to find the A inverse. then I just have to multiply that with b, and after multiplying whatever I will get, I'm equating that with x, and we'll get the value of x, y, and z. So talking about this particular page or this particular concept, so what I've learned over there, we are finding three matrices: coefficient, variable, and constant matrix. Then product of coefficient and variable matrix equals to constant matrix will generate the equations back. Then we did some criteria that to find the x, and x becomes equals to a inverse into b. So clear? And don't bother. Still, if you find any doubt, you can clear that with me. Not an issue. Now, as we need here a inverse, we already having x, we already having b. What we don't have is a inverse. Let's find a inverse. So this a inverse you are not going to copy from here, rather you gonna solve this on your own, as you have learned in previous lectures. What I find here is a determinant, then what I find here is the minors, then what I find here is the cofactors, then what I find here is the adjoint of a, then finally what I find is the inverse of a. So this is our inverse of a. And one thing you should notice, although I can multiply this 1 by 2 with the whole matrix, but I'm not doing that because sometimes it may create fractions that we are avoiding. So don't multiply this with the matrix at first step. Keep it as it is for the last step. Okay. So next I'm going to substitute the values. As we know, x was equals to a inverse into b. I'm substituting the value of x. It is x, y, z. Then I'm substituting the value of a inverse that we find just now, 1 by 2 times this matrix, and b matrix, that is 3, 4, 1. Now I'm multiplying these two matrices, and we know that during multiplication what we do, we are multiplying row with the column. So I'm multiplying first row with the first column. 2 into 3, 6, minus 2 into 4, minus 8, 4 into 1, 4. Okay. Likewise, now second row, first column, second row, first column. So 1 into 3, 3, 0 into 4, 0, minus 1 into 1, minus 1. Third row, first column, minus 1 into 3, minus 3, 2 into 4, 8, minus 3 into 1, minus 3. Solve them. 6 and 4, 10, minus 8 is 2. 3 minus 1 is 2. 8 minus 6 is 2. Now, at this step, you can multiply 1 by 2 with each. It becomes 2 by 2, 2 by 2, 2 by 2. Cancel them. And it becomes 1, 1, 1 and 1. As both matrices are equal, so that means first element is equals to first, second equals to second, third equals to third. Order is also same. So x is 1, y is 1, and z is 1. That is how you're going to solve your particular question of solving equations by using matrix method. That is quite easy. That is quite simple. There's no magic, no tough part over there. It's quite simple. Just find the determinant and find the inverse, just multiply that with the b, and we will gonna get x, y, z. Already all things you have done earlier as well, so it's quite easy. Go through that, then we'll gonna give you guys with the assignment that you gonna complete that. Okay. In case of any queries, you can WhatsApp me, and you can ask your doubts from me anytime. So keep learning, stay tuned. Thank you. Bye bye.